Hi, my name is Drew Larsen. I'm the Director of Business Development for ASI Mining. I'm excited to be here today to talk a little bit about how ASI participates with Enaex in providing autonomous solutions in their blasting applications. A little bit of an introduction to who is ASI and what we do. We are part of a group of companies that have automation solutions across the spectrum of industries, from automotive, agriculture, construction, etc. Mining being one of those. We're partnered with Epiroc as a minority shareholder that participates with us in our distribution and support base for our ASI Mining business. ASI Mining covers a variety of different autonomous capabilities, ranging from driver assist, assisting with manned vehicle operations to provide additional capabilities and enhancements to make things more efficient and safe. Remote control, which is line of sight operation of machines from a distance. Teleoperation further removed from the machinery, and scaling up to semi-autonomous, which starts to add some autonomous functionality and algorithms in the teleop solutions. Really leading up to a full autonomous capability where all of the functionality is really performed through a series of algorithms to control the vehicles. So we do cover this full spectrum of capabilities that we work with. Some of the unique differentiators that what makes ASI as a technology provider different than other applications is really the degree of being OEM agnostic, being able to work with a variety of makes and models of equipment, something very helpful in an application like blasting. Highly retrofittable, so not only with new machines, but things that can be retrofit to existing machines, even older machines that date back prior to any kind of drive-by-wire capability that have to be retrofit. Interoperable with legacy systems, like fleet management is one of those applications where we've integrated with fleet management systems, as opposed to having to require a full change out of the full technology stack. We try to integrate with legacy systems such as fleet management, and then interoperable with participating OEMs. We welcome and encourage participation by OEM partners and allow open access to our protocols to be able to integrate with a third-party OEM to automate that vehicle as a plug-in to our automation solution. And an agnostic integration platform. So really this platform is all about a broad autonomy and the kinds of applications that can plug into it. You'll see as far as the pedigree of ASI Mining is concerned, we started quite a while ago, back in 2006, in the automation space for mining, automating Cat 777s in the Arizona desert back in 2006, working with articulated dump trucks, dozers, wheel loaders, etc. In 2016, we started working with Enaex on their semi-autonomous blasting capability, really around ANFO and stemming operations, and being able to position those trucks in a way that Enaex could then leverage those as part of their solution with autonomous blasting. We've continued to work with other companies and mining operations. In 2018, we started working with Barrick on a fleet of Komatsu 930 trucks in the Nevada desert. Currently working with Fair Expo in the Ukraine on a fleet automation of Cat 793Ds, and then Roy Hill in Western Australia, which is a large installation of trucks. Just to showcase a little bit of some of these, the beneficial uses of autonomy. Really, driving around safety is the first and largest contributor for autonomy. By removing operators from harm's way, we definitely can increase the safety of mining operations. The nice thing in autonomy has been that there have been no human injuries or fatalities that have been experienced from autonomous operations in the mining industry so far. So we're very pleased about that. The biggest financial benefit really comes from utilization of availability of a truck, whatever asset is being automated. Typically we see anywhere from 15 to 20% increase in that utilization of availability through autonomy by eliminating things like shift changes and breaks and other human caused delays that are not leading to productive use of the assets. So that definitely is the biggest driver of autonomy. But also efficiency. Efficiency really comes from following a rule-based system that can be programmed into an autonomous system that makes our operations more and more optimized and less variable. So getting to parity with manned efficiency is the first and foremost, but then going beyond that, and projections are anywhere between 100 to 115% of average manned operational efficiency is expected for autonomous systems. Things like maintenance and tires and all tire life can also be impacted through autonomy as we apply the standard rules and really operate the machines in accordance with the OEM parameters to really optimize things like tire life, for example. And projections there are as much as 10% or more that can be derived from or can be reduced in terms of tire costs or maintenance costs. You can kind of see in the autonomy world there's been a lot of public statements that have been made by big tier 1 companies that have been users of autonomy for a while. Folks like Rio Tinto have been operating autonomy for several years, stating productivity increases by an average of 15%, load haul cost reduction by 15%, FMG similar, up to 30% increase in productivity, BHP, Imperial Vale, all making statements in the similar fashion of gains in efficiency and productivity ranging up to 20 to 30% even, reducing the number of trucks and reducing even their fuel and maintenance costs. So definitely being more and more widely understood as we continue to see more and more benefit statements coming out of early adopters. So a couple of examples of our OEM agnostic field autonomous solutions that have been fielded. This one, as mentioned earlier, is at Roy Hill. A couple of notable things about this project. It's a very large project consisting of 77 total haul trucks of 2 makes and models, Cat 793Ds and Hitachi EH5000 trucks that all operate under a Wenco fleet management system. These trucks are part of a network of up to 250 total assets that will have either situational awareness in addition to the autonomy that's factored in. And we use what's called V2X technology to help supplement the communications between vehicles in addition to vehicles to a central server. Very ambitious project, and we're well into phase 2 out of a 3-phase project in Western Australia that's ongoing. Another example I'd like to talk about is at Fair Expo. This is in the Ukraine. It's an iron ore mine that is leveraging autonomous technology to convert a fleet of Cat 793Ds. Currently operating 6 autonomous trucks and will expand up to 15 trucks in the 2nd phase of this project. One interesting thing about this project, it's one of the first and maybe only instance where we're actually loading autonomous haul trucks from a drag line. This also features an integration with Wenco fleet management system, and again is an exciting first entry of autonomy in the CIS in Ukraine. So interoperability, something we want to spend, well, we talk a lot about this, we want to spend a little time talking about what that really means. A great way to illustrate that is through this architectural drawing of our particular autonomy stack. Starting at the top with the fleet management system, and again, as mentioned before, really can be any third-party fleet management system provider. We hope to be able to integrate with a legacy fleet management system, such that the mine operator can keep that investment that they've made in fleet management in place as they contemplate adding autonomy. The second drawing there, TMS, really stands for Traffic Management System. It's the autonomy layer. Our software is called Mobius. And Mobius is really what takes the assignments from a dispatch system like fleet management and really executes that in the autonomy layer to give those assignments to autonomous vehicles. Down at the vehicle level, there's two modules there, a VAK, which is called a Vehicle Automation Kit. That is a standard piece of hardware that goes on really every make or model of vehicle. It includes sensors and different componentry with the processing capabilities that make up the Vehicle Automation Kit. That is paired with a drive-by-wire actuation kit that is model specific. That drive-by-wire is really based on the unique make and model of the vehicle, and so it will be customized based on the type of vehicle that we're using. That can be supplied either by ASI or by a third-party OEM using an interface control document or ICD that really defines the interface between a third-party OEM supplied drive-by-wire solution and an ASI VAK. So we therefore invite actively participants on the vehicle side to be able to interface with our solution at that level or at the fleet management level, as you see here. Again, it's just an example of how interoperability actually works and those interface points where we can actually invite that participation with third parties. This is a brief slide here just showing where the position of the sensors and the vehicle automation kit is placed typically on a haul truck, where you see forward-facing LiDAR and radar units that are part of our vehicle automation kit, and the box is integrated in with the truck in convenient locations. So again, this is a standard component that goes on any vehicle that we automate and interfaces with a drive-by-wire. Liebherr is one example where we've actually been able to integrate with a third-party OEM to integrate their system into our Mobius solution. We announced this several years ago, and Liebherr continues to be an example of an OEM that can interface with an agnostic system like ASI. Want to talk about scalability and integration. So we talked a lot about haulage today, and really if you look at a kind of an architectural depiction of that solution, this is one way to visualize that. At the system level, having a fleet management system that sits at the top provides that dispatch information to a traffic management level, which is really at that control or command level. And that, in our case, is called Mobius, as I mentioned, with Mobius having application licenses. And those licenses really look at things like haulage, manned applications for manned vehicles that would work in an autonomous haulage application. And then at the actual vehicle level, again, the VAK, the Vehicle Automation Kit, and a drive-by-wire solution, along with situational awareness devices for man. So this would be kind of the depiction of a haulage, an autonomous haulage application. If we take and look at how would we scale a solution like this and bring in something like blasting, the Enaex program that Enaex is working on. The blasting program becomes an extension of this autonomy platform by plugging in a Mobius for blasting application license, and then at the vehicle level having the onboard hardware vehicle automation kit that would plug that into our autonomy platform. So this is a natural way to extend that autonomy platform and scale it across these applications. But we can go further with this all the way through things like third-party autonomous drill integration, which was recently announced with Epiroc at the show, and then teleop applications, things like dozers, wheel loaders, or other applications. all that can be integrated into this common autonomy platform so that these autonomous solutions work together in an integrated fashion as opposed to having to maintain pure isolation from each other. Covering the blasting solution in particular, this we're very excited to have been partnering with Enaex for several years to provide semi-autonomous navigation of ANFO and stemming trucks in this autonomous platform. What that's done is improve safety. We can look at things like reduced cycle time, and then also looking at opportunities to provide data sharing between applications like the drill and the blasting process. So these are all things that are on the horizon for our blasting program with Enaex. Here's a brief video I'd like to show you. So that video really shows off some of the capabilities we've been able to work with Enaex on to establish that semi-autonomous capability that really provides a lot of improvement in terms of the ability to mine in hazardous situations and really leading to other benefits for our customers moving forward. What is the future of autonomy in mining? And in the case of ASI and our autonomy partners like Enaex, really looking to do things like continuously improve the value proposition for our customers by enhancing the KPI performance of these autonomous systems. It's not enough to just have the machines operate in these spaces. We really need to look at unlocking value and finding ways to increase performance, to unlock more opportunities for savings in both things like utilization benefits, efficiencies, along with safety and the other drivers of benefits in autonomy. Furthermore, we're continuing to expand the autonomous applications that cover a larger portion of the mining ecosystem, really providing capabilities across different vehicles and different application types, and really continue to flesh out that building of the whole scalable autonomous mining capabilities. In areas where we have semi-autonomous functionality, we're eager to continue to move that to full autonomy, really unlocking more and more value for our customers through making more of those fully autonomous applications. And then finally, really it's the ability and the interest of integrating data between systems to really optimize the operations on an autonomous standpoint that are fueled by data that's been optimized and really guiding the autonomous systems to greater efficiency and capabilities. This really leads up to this kind of vision of a fully integrated autonomous mining operation where we're really covering the full ecosystem of mining, where all of these applications, whether fully autonomous or semi-autonomous, are all integrated, sharing a common operating zone and really negating the need for isolation between these applications. This is the big opportunity for an integrated platform like the Mobius platform from ASI. With that, it's always a pleasure to be part of an exciting opportunity with partners like Enaex that are really doing some incredible things in this space of autonomous mining. Thank you so much for your time today.